silence falls over the Giza plateau as the last tourists board their buses. The vendors pack up their trinkets, the camel handlers lead their animals away, and slowly the chaos of the day dissolves into the stillness of the desert night. The Great Pyramid stands as it has for thousands of years, casting its impossible shadow across the sand. In the gathering darkness, it seems less like something built by human hands and more like a mathematical equation carved into the earth itself. Too perfect, too ancient, too silent. For most of human history, we have asked one question about this monument. Who built it? The answer, we are told, is simple: the Egyptians. Specifically, a pharaoh named Khufu around 2560 BC during Egypt's 4th dynasty. The story fits neatly into textbooks. It satisfies our need for answers, but the more closely archaeologists, geologists, and engineers examine this structure, the more that neat little story begins to unravel. What if the Great Pyramid was not built by the Egyptians at all? What if they simply found it, already ancient, already weathered by time, and claimed it as their own? Tonight, we follow a trail of evidence that mainstream archaeology would prefer to ignore. We examine dates that do not match, erosion that should not exist, and precision that defies explanation. We look at a monument that may predate recorded history itself. And if that is true, then everything we think we know about the origins of civilization may need to be rewritten. Because the stones do not lie, and they are telling a story far older than Egypt. The official narrative begins around 2580 BC. Egypt is in its golden age, the 4th dynasty, a time of centralized power and monumental ambition. Pharaoh Khufu, known to the Greeks as Cheops, orders his architects to construct a tomb unlike anything ever attempted, a structure that will secure his passage into the afterlife and declare his divine authority for all eternity. The logistics sound impossible. More than 2.3 million limestone blocks, each weighing an average of 2.5 tons, quarried from sites across Egypt and assembled with such precision that the finished pyramid rises 146 meters into the sky. The entire project, according to Egyptologists, took just 20 years. That means workers would have had to quarry, transport, and place one massive block every 2 minutes, 24 hours a day, for 2 decades straight. Even today, with hydraulic cranes, laser-guided systems, and industrial machinery, no construction company has matched this speed or precision on a project of comparable scale. Yet we are expected to believe that Bronze Age labourers accomplished it with copper chisels, wooden sledges, and rope. The story does not just stretch credibility, it snaps it. But where does this story come from? Not from ancient Egyptian records, not from wall paintings or papyrus scrolls detailing the construction. The first written account of the pyramid's construction appears nearly 2,000 years after it was supposedly built. Around 450 BC, a Greek historian named Herodotus travelled to Egypt and spoke with local priests. They told him stories of ramps, quarries, and massive labour forces that toiled for decades. But Herodotus also recorded tales of flying machines and sacred magic that lifted the stones into place. Details modern historians conveniently omit. Herodotus was not a liar, But he was not a scientist either. He was a collector of stories, part historian, part mythographer. He reported what he was told, mixing fact with folklore. Yet every modern classroom lesson about the Great Pyramid begins with his second-hand testimony. For 2 millennia, his words were all we had. Then came the 19th century, the age of colonial archaeology, when European explorers descended on Egypt like prospectors on a gold rush. Among them was a retired British military officer named Colonel Richard William Howard Vyse. Unlike patient scholars who carefully excavated sites, Vyse brought something else to Giza: gunpowder. In 1837, obsessed with making a discovery that would cement his legacy, Vyse used explosives to blast through sealed chambers inside the Great Pyramid. His workers, horrified by the destruction, watched as he blew apart ancient stone with dynamite. After months of demolition and nothing to show for it, Vyse finally struck gold. Or so it seemed. While tunnelling upward from the so-called King's Chamber, his team breached a series of small spaces later named the Relieving Chambers. On the granite beams of the highest chamber, his men reported finding faint red painted marks, hieroglyphic symbols, and among them a royal cartouche containing the name Khufu. Vyse announced the discovery with triumph. This was the proof the world had been waiting for, the builder's signature painted directly onto the pyramid's internal structure. Overnight, the mystery was solved. Textbooks were rewritten, museums updated their plaques. The Great Pyramid was Khufu's tomb, and the case was closed. But was it? Years later, when other Egyptologists examined Vyse's discovery more closely, something felt wrong. The markings were painted, not carved. Royal inscriptions in Egyptian tombs were always carefully chiseled into stone, not hastily brushed on like graffiti. Some of the hieroglyphs were misspelled, errors no trained scribe would make. Even stranger, the mistakes matched hieroglyphic examples in a British reference book published just years before Vyse's expedition. A book that Vyse himself owned. Under modern analysis, the red ochre pigment used in the markings appears unusually bright, lacking the micro-cracking and fading expected of paint that is 4,500 years old. Pigment experts noted that the paint sits on top of quarry marks, meaning it was applied after the blocks were already in place, not during construction. If the inscriptions were genuine, they should have been buried beneath millennia of dust, not gleaming on the surface. But Vyse's proof was too convenient to question. It gave Egyptology the solid foundation it desperately needed. From that moment forward, the Great Pyramid was officially dated to Khufu's reign, and everything else, the engineering theories, the cultural interpretations, the historical timelines, was built on top of that one fragile piece of evidence. When archaeologists searched for corroborating proof, they found almost nothing. No papyrus scrolls from Khufu's reign describe the pyramid's construction. No wall paintings depict the workers or the tools they used. Even Khufu's own statue, discovered at Abydos, is tiny, barely 10 centimeters tall. For the builder of humanity's largest stone monument, the archaeological silence is deafening. It is as if the pyramid existed before Khufu and he simply attached his name to it. Meanwhile, later pyramids that are officially attributed to other pharaohs contain detailed inscriptions, decorative chambers, and clear evidence of their builders. The oldest and largest pyramid has none of this. It is anonymous. Some scholars argue that the pyramid city discovered near Giza in the 1990s proves a massive workforce lived there during Khufu's time, and it does prove workers lived there, but radiocarbon dating of pottery, animal bones, and charcoal from the site spans several centuries, not a single 20-year construction period. The evidence suggests long-term occupation, maintenance, and ritual activity, not original construction. Then there is the erosion. Along the pyramid's base and the nearby Sphinx enclosure, geologists have identified weathering patterns inconsistent with Egypt's desert climate. Deep vertical channels carved into the limestone resemble water runoff, not wind erosion. This observation, first made by geologist Dr. Robert Schoch in the 1990s, ignited one of the fiercest debates in archaeology. Schoch argued that the erosion was caused by heavy rainfall, the kind that ended in the region thousands of years before Khufu's time, during the wetter climate of the early Holocene. If correct, it would mean the monuments predate Egypt's desert phase entirely, belonging to an era when the Sahara was green. Orthodox archaeologists rejected Schoch's conclusion, insisting the erosion was caused by wind and sand. But wind erosion creates horizontal patterns, not vertical ones. The grooves carved into the Sphinx enclosure run top to bottom, consistent with water cascading down the walls during periods of sustained rainfall. Nature, it seems, left its own timestamp in the stone. A timestamp we have chosen to ignore. Skepticism of the official story is not new. From the Renaissance onward, travelers described the pyramid not as a tomb, but as a mystery. In the 17th century, astronomer John Greaves measured its dimensions and noted geometric ratios that went far beyond practical architecture. In the 20th century, engineer Flinders Petrie found the pyramid's base so perfectly level that it deviated by less than 2 centimeters across its entire 230-meter perimeter. The deeper researchers looked, the less the narrative of copper tools and slave labor made sense. Yet the story persists because it is simpler to believe in human ingenuity than to confront the possibility of collective amnesia. What keeps the official narrative alive is not evidence, but repetition. Centuries of scholars, tour guides, and institutions reinforcing the same comfortable truth. To question it feels almost heretical, a challenge to our understanding of human progress. But the stones themselves are indifferent to pride. They tell a quieter, older story, one we have barely begun to translate. And that story begins not with a pharaoh's ambition, but with an absence. The missing proof that Khufu ever laid a single stone. To understand what might fill that void, we need to return to the chamber Weiss claimed to discover and examine the evidence not as history decrees, but as science now reveals. Because if those red markings are not authentic, then the entire foundation of Egyptian chronology begins to crack, and the pyramid becomes something far more ancient than anyone is willing to admit. The man behind that controversial discovery, Colonel Richard William Howard Weiss, was not a trained archaeologist. He was a wealthy British officer with a fascination for ancient mysteries and a reputation slowly crumbling under financial pressure. Egypt in the 1830s was the Wild West of archaeological exploration, a place where fame could be carved from sand and stone if you had the resources and the will. Men like Giovanni Belzoni, an Italian strongman turned tomb raider, had become legends by unearthing statues and mummies for the British Museum. Vice wanted the same immortality, but when he arrived at Giza, he found himself overshadowed. A young Italian explorer named Giovanni Caviglia had already begun mapping the pyramid's interior chambers and had gained the support of local officials. Frustrated, Vice used his wealth to outbid and outmaneuver his rival, hiring more workers, bribing guards, and eventually locking Caviglia out of the site entirely. He took control of the pyramid the way generals seize fortresses. Then he began blasting. In his own journal, Operations Carried On at the Pyramids of Gizeh, published in 1840, Vice describes how he used gunpowder to breach sealed passages and chambers. The explosions cracked ancient granite, sending shockwaves through corridors that had been silent for millennia. To later Egyptologists, this approach bordered on vandalism. To Vice, it was determination, but after months of destruction, he still had nothing to show. No treasures, no inscriptions, no discovery worthy of fame. His funds ran low. His reputation among fellow explorers began to collapse. Then, in late March of 1837, his luck changed, or appeared to. While tunnelling upward from the King's Chamber, Vice's team breached a series of narrow spaces designed to distribute the pyramid's immense weight. On the granite beams of the highest chamber, later named Campbell's Chamber, his men reported finding faint red painted markings. They were roughly drawn, scattered across the stone like graffiti. Among them was a cartouche reading Khufu. Vice announced the discovery with triumph. To him, this was the missing link. The builder's signature, painted into the heart of the monument. Newspapers across Europe celebrated the find. Egyptologists finally had their proof. The Great Pyramid belonged to Khufu. The textbooks were rewritten. The debate was over. But from the beginning, something about the marks did not fit. Unlike the carved hieroglyphs found in royal tombs, these were crudely painted, uneven, almost rushed. Some overlapped construction guidelines, quarry marks used to align blocks during assembly. If the inscriptions were original, they should have been placed before the stones were sealed into position, not painted on afterward. Others contained spelling errors. The hieroglyph for Khufu used a symbol that did not exist during his reign. Incredibly, that same mistake appears in a hieroglyphic reference book published in London just years before Vice's expedition, a volume Vice owned and cited in his personal notes. Modern researchers, including author Zechariah Sitchin and investigator Scott Crichton, have studied photographs and tracings of the marks. They point out irregularities invisible to the casual eye, brushstrokes inconsistent with ancient painting techniques, pigment that lies above dust layers rather than beneath them, strokes that end abruptly as if drawn from awkward angles by someone standing on scaffolding in a confined space. Some marks even run beneath chisel lines left when Vice's team later extracted samples from the chamber, a clear indication the paint was applied recently, not millennia ago. Chemical analysis conducted in the late 20th century revealed another troubling detail. The red ochre pigment shows no crystallization or mineral breakdown, processes that affect ancient paint after thousands of years of exposure. Under magnification, it looks disturbingly modern. And then there is the most suspicious detail of all. The absence of any mention of the marks in Vice's assistant's original field notes. The first clear reference to the cartouche appears only in Vice's later journal entries. written after he had dismissed or fallen out with several of the foremen who first entered the chamber. A pattern begins to emerge, one not of discovery but of desperation. Imagine Vyse on that night in 1837, broke, mocked by rivals, out of time. One stroke of fortune could transform him from a failure into a legend. All he needed was a pharaoh's name. A few painted hieroglyphs copied from a reference book, applied in the dark with red pigment and a brush, and the course of Egyptology would be changed forever. Was it forgery? We cannot say with absolute certainty, but even cautious historians admit the inconsistencies are deeply troubling. Richard William Howard Vyse Jr., the Colonel's own descendant, wrote that his ancestors' accounts were laced with contradictions. Egyptologists rarely discuss this publicly. The foundation of an entire chronology depends on those red marks being genuine, because if they are not, if the name Khufu painted in the pyramid is a Victorian fabrication, then the monument becomes undated. It could belong to the Bronze Age, it could belong to the Ice Age, and that opens a door no one in orthodox archaeology wants to walk through. In 2011, advanced digital photogrammetry allowed researchers to re-examine high-resolution images of the chamber using filtered light. The red marks showed modern layering, brush fibres embedded in the pigment, a technique unknown to ancient Egyptian artisans who used reed pens or finger application. When scientists compared the mineral composition of the ochre with known Old Kingdom pigments, they found subtle chemical differences, traces of industrial iron oxide consistent with 19th century paint sources. Still, official institutions refused to permit further sampling. The Great Pyramid, they said, must be preserved. But sometimes preservation means protecting a narrative rather than protecting stone. The irony is striking. The entire chronology of ancient Egypt, its dynasties, its pharaohs, its cultural sequence, leans on a few centimetres of red pigment discovered by a man using dynamite in a desperate rush for fame. If those marks are younger than the pyramid itself, then every date that depends on them begins to drift backward into an era we do not remember. And so the name painted in red, meant to close the case, becomes the beginning of a new one. The true story of the Great Pyramid does not end with a British explorer's brushstroke. It begins there. Because the moment we admit that its authorship might be uncertain, we must confront the next question. When was it actually built? To answer that, we need to leave Vyse's 19th century scandal behind and follow the scientists who tried to measure time itself through carbon, stone, and starlight. And what they discovered is that the pyramid does not just defy forgery, it defies dating. Dating a structure made of stone sounds straightforward until you actually try. Stone itself contains no organic material, no carbon to measure, no biological clock to read. It does not decay, it endures. To science, bare stone is mute. And so archaeologists have spent decades trying to make the pyramid speak in other ways, through mortar, through relics, through association. But each time they do, the evidence fractures into contradictions that refuse to resolve. The first serious attempt to date the Great Pyramid scientifically came in 1984. Egyptologist Mark Lehner and a team of researchers funded by the Edgar Cayce Foundation undertook a radiocarbon study of the pyramid's mortar. The technique, known as carbon-14 dating, measures the decay of radioactive carbon isotopes in once-living material. Tiny remnants of straw, charcoal, or plant fibre embedded in the ancient lime plaster. Their results, published in Archaeology magazine, seem to confirm the orthodox view. Dates clustered around 2500 BC, conveniently matching Khufu's supposed reign. Egyptologists celebrated. The Great Pyramid, they said, had finally been scientifically dated. But a closer reading of the data tells a different story. The samples varied wildly, some dated as much as 380 years older or younger than Khufu's reign. One fragment even dated closer to 3000 BC, centuries before his dynasty existed. The team attributed the discrepancies to old wood, organic material reused from earlier generations. But that explanation, while tidy, glosses over a deeper problem. It assumes what it is trying to prove. If the pyramid's date is already known, then the data must conform. If it does not conform, it is dismissed as contamination. Yet the scientific reality is messier. Mortar represents not original construction, but maintenance. Over millennia, the pyramid has been repaired repeatedly by pharaohs, priests, and modern restorers. What the 1984 study actually measured could have been anything. Patchwork repairs during the Old Kingdom, material inserted during medieval restoration. The carbon-14 test does not tell us when the stone was laid. It only tells us when the last living fragment mixed into the mortar died. To put it simply, dating the mortar is like dating the dust on your bookshelf and calling it the age of your house. Later studies deepened the confusion. In the 1990s, researchers from the University of Zurich reanalyzed similar samples and again found broad discrepancies, some as much as 1,000 years apart. A few pieces even predated the entire Egyptian civilization as we know it. When independent researchers requested new samples to test with updated technology, access was abruptly denied. Official statements cited preservation concerns. Unofficially, no one wanted more anomalies cluttering the narrative. Then, in 2020, an accident in a Scottish museum changed everything. While cataloguing old donations at the University of Aberdeen, curatorial assistant Abir Eladani stumbled upon a small cigar box wrapped in a 1946 newspaper. Inside lay a splinter of cedarwood, dark, dry, and carved into a rod-like shape. A faded label read, "From the Great Pyramid, Dixon Relics." This was no ordinary souvenir. In 1872, British engineer Wayneman Dixon had discovered 3 small objects hidden in one of the pyramid's narrow shafts: a granite ball, a bronze hook, and this cedar fragment. The first 2 objects ended up in the British Museum. The wooden piece vanished for more than a century. When Eladani found it, she sent it for radiocarbon dating at independent labs. The results stunned everyone. 3,341 to 3,094 BC. That places the wood 500 to 800 years older than Khufu's lifetime, older even than Egypt's first recognized pharaohs. The explanations came quickly. Some scholars claimed cedar trees could live for centuries, so the wood might have been ancient when it was used. Others argued contamination. But the fact remains, this is the only direct organic artifact found inside the pyramid structure, and it places the monument's material at least half a millennium before its supposed builder was born. If true, that single splinter of wood could rewrite history. Or more accurately, restore a version we have forgotten. Consider another case. At Saqqara, The step pyramid of Djoser, officially older than the Great Pyramid, shows erosion patterns strikingly similar to those at Giza, even though its masonry is softer. If both experience the same level of weathering, logic suggests they endured similar spans of time. But Egypt's dry climate over the past 5,000 years cannot account for the deep vertical channels cut into the stone. Those require centuries of heavy rain, the kind that ended around 5000 BC when the Sahara transformed from savanna to desert. That observation aligns with geological data. Sediment cores from the Nile Valley reveal high flood layers dating back more than 7,000 years when the region was far wetter. If the pyramid shows water erosion from that era, then its lower courses could predate Egypt's known dynasties by millennia. Even the ground around the pyramid whispers the same story. Beneath the sand, archaeologists have found limestone pavement so heavily eroded it suggests exposure to rainfall long vanished from the region's climate record. The Sphinx enclosure beside the pyramid displays the same telltale signatures, deep, rounded grooves carved by water, not wind. Geologist Dr. Robert Schoch, after detailed stratigraphic study, concluded that the erosion occurred between 9000 and 7000 BC, an age consistent with the late Ice Age's final floods. If that analysis is accurate, the Sphinx and the Great Pyramid belong not to Khufu's Egypt, but to an earlier world. A world that disappeared when the Sahara dried and civilization rebooted. Still, Orthodox archaeology resists this conclusion because it destabilizes everything built upon it, not just Egypt's timeline, but humanity's. If the Great Pyramid is older than writing, then the history of civilization stretches back not 5,000 years, but perhaps 12,000, deep into the Younger Dryas, when global sea levels rose and ancient coastlines drowned beneath the waves. The question then shifts from who built it to what were they trying to preserve. When engineers analysed the pyramid structure using luminescence dating, a method that measures trapped electrons in minerals to determine when stone was last exposed to sunlight, they found inconclusive results. Some blocks registered ages older than Khufu, others younger. Even the light trapped in the crystals refuses to confirm the official story. The pyramid resists measurement the way a mountain resists naming, and so scientists have begun to treat it as what it may truly be: a palimpsest, a structure built in layers across time, perhaps an ancient core refurbished by later dynasties, repurposed as a royal tomb, then as a temple, then as a symbol. A monument so old that each civilization simply claimed it anew. In that sense, Khufu may not have built the Great Pyramid at all. He may have merely inherited it, restored it, and left his name where earlier hands had long vanished. The carbon fragments, the cedar wood, the uneven data, all hint that beneath Egypt's known history lies a deeper, older foundation. The Great Pyramid, it seems, does not belong to any one era. It belongs to time itself. But if its age stretches back into the hazy twilight of prehistory, then the next question follows naturally. How was it built? Because the further we push its origins into the past, the less sense its construction makes, until we are forced to confront an impossible reality. That the technology behind it did not simply precede Egypt. It may have preceded everything we know as civilization. Imagine standing on the Giza Plateau thousands of years ago, perhaps 4,000 years, perhaps far longer. You watch thousands of men move in rhythm beneath the blazing Egyptian sun. Dust hangs in the air. drums beat, ropes strain as stone blocks the size of buses inch forward across the sand. That is the picture we have been taught to believe. The power of human will against the immovable. The miracle of manpower building the impossible. But when we translate that image into numbers, into engineering, into actual physics, the story begins to crumble. The Great Pyramid is not just big, it is mathematically absurd. It rises 146.6 meters high. Its base covers over 13 acres, an area large enough to fit St. Peter's Basilica, Westminster Abbey, and the cathedrals of Florence and Milan combined. Each side aligns almost perfectly to the cardinal directions. Its total weight is approximately 6.5 million tons. To finish such a structure in 20 years, as textbooks claim, would require moving and setting 2.3 million blocks, averaging 2.5 tons each. That is roughly one stone every 2 minutes, 24 hours a day, for 2 decades straight. Even today, with hydraulic cranes, bulldozers, and laser-guided equipment, no construction project of that scale has achieved such speed and precision. Now imagine doing it all with copper chisels and stone hammers. Copper measures 3 on the Mohs hardness scale. Granite, the stone used for the pyramid's inner chambers, ranks between 6 and 7. In modern laboratory tests, copper chisels barely scratch granite before bending. Experimental archaeologist Dennis Stocks tried to replicate ancient cutting techniques. After hours of hammering, his team managed to cut a few millimeters into limestone, but the tools wore out faster than they cut. Against granite, they were useless. To shape just one of the 80-ton granite beams in the king's chamber using such tools would require thousands of chisels, constant reforging, and months of labor per block. Multiply that by hundreds, and the logistics become unthinkable. Archaeologists have long suggested that the Egyptians used dolerite pounding stones to chip away at granite surfaces, but even dolerite is brittle. Photographs of ancient quarries at Aswan show circular pits and straight tool marks that look more like drilling than pounding. When engineers studied these grooves under magnification, they discovered spiral striations, the signature of a rotating tool, not a hammer. The grooves descend in continuous helical patterns consistent with a rotary drill bit, as if the stone had been carved by high-speed machinery. To test this, engineer Christopher Dunn, a precision manufacturing expert, created computer models of these marks. The result showed that the feed rate of the tool, how fast it cut through granite, was equivalent to a drill spinning thousands of times per minute, applying pressure far beyond what human hands could manage. In modern industry, similar marks appear only on materials shaped by diamond-tipped tools or ultrasonic cutting equipment. If ancient Egyptians achieved the same pattern with copper tubes and sand, as orthodoxy claims, they would have needed centuries to complete the inner chambers alone. Transportation adds another layer of impossibility. Some granite beams inside the pyramid weigh up to 80 tons and were quarried in Aswan, over 800 kilometers to the south. How were they moved? The Nile would have offered a natural highway, but physics intervenes. The buoyant limit of a wooden barge of that size would be exceeded by even a fraction of that weight. Modern naval engineers recreated such a barge design in the 1990s. The moment they loaded it with 60 tons of granite, the vessel cracked and sank. Even if they somehow managed to reach Giza by river, how were the stones hauled from the riverbank up the plateau? Orthodoxy proposes ramps. Yet to achieve the necessary incline for a smooth pull, such ramps would have stretched for over a mile and contained more material than the pyramid itself. Not a single trace of such a ramp survives. Not foundations, not spoil heaps, not the massive quarries of clay required to build it. Some suggest a spiral ramp wrapping around the pyramid's exterior, but this too fails under scrutiny. A ramp curling upward would obscure the builder's sightlines, making precise corner alignment impossible. It would also require the removal of millions of tons of debris once construction ended, work for which no evidence exists. Modern experiments have tried to put these theories to the test. In 1978, the Nippon Television Corporation of Japan, working with Egypt's Supreme Council of Antiquities, set out to build a miniature replica of the Great Pyramid using only materials and techniques supposedly available to the ancients. Their pyramid would stand 20 meters tall, a fraction of the original. From the start, it was a disaster. Copper chisels failed to shape even small limestone blocks. Ropes snapped. Workers could not drag the stones across sand without lubrication, so they poured water to reduce friction, an ancient technique hinted at in wall paintings. But the sledges still bogged down. Eventually, the team resorted to modern steel tools and diesel-powered cranes just to lift the smaller blocks. Even then, their pyramid reached only 10 meters, half their target, before the project was abandoned. The conclusion, quietly noted in their final report, was that no known ancient technique could account for the precision or scale of the Great Pyramid's construction. To match the precision of Giza today, engineers would need laser alignment systems, GPS calibration, and hydraulic cranes capable of lifting 100 tons. Yet somehow, according to mainstream history, Bronze Age builders accomplished it with nothing more than rope, wood, and human sweat. Let us pause to visualize it scientifically. Each side of the Great Pyramid measures 230.4 meters. The difference in length between its longest and shortest sides is less than 2 centimeters. The base is leveled to within 1.5 centimeters across 13 acres, a level of precision equivalent to modern high-rise construction. The structure's orientation to true north deviates by just 3 arc minutes, 0.05 degrees. Even the Hubble Space Telescope, built with computers and lasers, has a manufacturing tolerance in the same range. How does a Bronze Age society achieve accuracy rivaling modern aerospace engineering? Some researchers have proposed imaginative but testable hypotheses. The pyramid's geometry, its angles and proportional ratios suggests that the builders understood not only geometry but also geodesy, the curvature of the Earth. The base perimeter multiplied by 43,200 equals Earth's equatorial circumference. Its height multiplied by the same number gives the polar radius. These relationships are not arbitrary. They require knowledge of the planet's size, shape, and axial tilt. If the builders knew such measurements, they also possessed advanced surveying methods. But how? No evidence of such instruments survives from Khufu's era. Could it be that the pyramid we see is a reconstruction, a renewal of something older, built with tools or techniques since lost? The Egyptians themselves seem to hint at this. In temple inscriptions from Saqqara, priests describe records of the first time and plans of the ancestors, suggesting that the blueprints for these monuments were inherited rather than invented. The paradox grows clearer the more we look. The Great Pyramid is both simple and impossible. 4 triangles on a square base, yet executed with precision that humbles modern engineers. Its construction required understanding of mathematics, logistics, and material science that defies its alleged age. So if it was not built by 4th dynasty Egyptians with copper tools and sweat alone, then how was it built? The answer may lie not in what we have found, but in what we have refused to see. Stand at the base of the Great Pyramid and it is easy to be overwhelmed by its scale, but step closer, trace your hand along its surface, and something far stranger emerges. What first looks like rough, weathered stone becomes a study in impossible precision. Each block fits its neighbour with surgical accuracy. The seams between them are thinner than a sheet of paper. For centuries, scholars have tried to explain how Bronze Age masons could produce such perfection. Yet every answer dissolves beneath the evidence, leaving only the paradox itself. The oldest monument on Earth is also its most precise. Let us start with the measurements. When 19th century surveyor Flinders Petrie, one of the most meticulous field scientists of his time, took his instruments to Giza, he expected imperfections. What he found astonished him. The base of the Great Pyramid covers more than 13 acres, yet the height difference between its corners is less than 2 centimeters. The 4 sides deviate from true north by a mere 3 arc minutes and 6 seconds. That is 1/20th of a single degree. Even with GPS and lasers, modern engineers rarely achieve this on a project of that scale. How then could people working with rope, plumb bobs, and copper chisels produce such alignment? Egyptologists suggest that surveyors observed the stars, using the pole star Thuban in Draco to mark north. But astronomers have calculated that in 2500 BC, Thuban lay slightly off true north, enough to create a larger deviation than the pyramid shows. In fact, the Great Pyramid's orientation is more accurate than observatories built 4,000 years later. The deeper you go, the stranger it gets. The casing stones that once covered the pyramid, most now removed, were cut so precisely that modern restorers struggle to replicate them. Some joints measure less than 0.5 millimeter. Their surfaces are polished to optical flatness. Engineers from the French Institute for Research in Engineering and Construction studied surviving casing blocks in the 1990s and found tolerances comparable to precision-machined metal. One engineer described it as the accuracy of an airplane wing applied to millions of tons of rock. The foundation stones beneath the visible layers display similar mastery. Ground-penetrating radar shows interlocking bedrock terraces engineered to distribute weight evenly across the plateau. The result? After thousands of years of earthquakes, sandstorms, and temperature swings, the pyramid has not settled or shifted more than a few millimeters. To achieve that stability, its builders must have understood both load distribution and material expansion coefficients, concepts formalized only in the last few centuries. Even the internal architecture obeys laws of precision unknown to its supposed era. The Grand Gallery, a 47-meter passage rising toward the king's chamber, is constructed of granite blocks fitted so tightly that air cannot pass between them. The slope of the gallery, 26 degrees, matches exactly the angle of the pyramid's outer face, suggesting intentional harmonic resonance. The gallery's corbelled ceiling, each course projecting a few centimeters inward, reduces structural stress with mathematical efficiency. Such a technique was not rediscovered in modern engineering until the development of cantilever principles in the 19th century. And then there are the tool marks, tiny signatures carved into the stone. Inside the pyramid, on the granite beams of the king's chamber, lie spiral striations consistent with mechanical drilling. Engineer Christopher Dunn, a master machinist, measured the grooves and found a uniform pitch, meaning the cutting head advanced at a fixed rate, as though driven by a lathe or rotary drill operating at thousands of revolutions per minute. Laboratory tests using copper and sand drills failed to reproduce those patterns. The modern experiments left rough, irregular scratches, not the clean concentric rings visible on the ancient stone. The same precision appears on blocks at nearby temples. At Abydos, granite boxes cut from single pieces of stone show interior angles meeting at perfect right angles, verified by modern laser alignment tools. Their surfaces are flat to within 1/10,000th of an inch, a standard used today in aerospace manufacturing. Yet these artifacts are attributed to dynasties that supposedly lacked iron tools or advanced measuring instruments. To dismiss these anomalies as coincidence is to ignore the sheer consistency of precision across the site. Every block in the pyramid, millions of them, fits into a geometry so exact that when the structure was intact, the height-to-base ratio encoded the mathematical constant pi to 3 decimal places. Its side angles embody the golden ratio found throughout nature and later in the art of Da Vinci. The precision was not random, it was systemic, as if every dimension followed a unified design code. So how did they do it? The orthodox answer insists on simple tools, copper chisels, wooden mallets, dolerite pounding stones. But in repeated reconstructions at the Aswan quarries, at Saqqara, at the Japanese experiment in 1978, these tools fail spectacularly. Copper bends, dolerite shatters, and manual polishing produces nothing close to the measured flatness of Giza's granite surfaces. Other explanations verge on the speculative but remain grounded in physics. Some engineers proposed that the builders used abrasive slurry saws, copper blades combined with quartz sand and water to grind through granite. While plausible for small pieces, scaling the technique to 80-ton beams is unrealistic. Others suspect vibration cutting, harnessing sonic frequencies to fracture the crystal lattice of granite. Experimental ultrasonic machines today can slice through hard stone with surprising ease, but such technology belongs to the 20th century, not the 26th century BC. Then there is the possibility that the builders did not cut each stone individually at all, but cast them using a lost form of limestone geopolymer, a kind of ancient concrete. French materials scientist Joseph Davidovits proposed this in the 1980s, arguing that some outer blocks show microbubbles and binding textures consistent with reconstituted stone. If true, it would imply an advanced knowledge of chemistry and materials engineering. But when samples from deeper core blocks were tested, the results pointed back to quarried, not cast, stone. The mystery endured. Perhaps the real secret lies not in tools or materials, but in intent. The pyramid's geometry is not random, it is tuned. Acoustic tests reveal that the king's chamber resonates at 440 to 432 Hz, the same frequencies used to tune musical instruments and matching Earth's own electromagnetic resonance. The Schumann frequency, When sound is introduced, the entire chamber vibrates like the body of a colossal instrument. Was this precision a byproduct of artistry, or part of a design that harnessed vibration, sound, or energy in ways we barely understand? Even the choice of materials seems deliberate. The outer casing of high quartz limestone reflects sunlight, while the inner granite core, rich in quartz and feldspar, conducts and amplifies vibration. Modern engineers have noted that this combination creates piezoelectric effects, tiny electrical charges generated by mechanical stress. If that property was known and exploited, the pyramid might not have been a tomb at all, but a kind of resonant device using precision itself as a form of power. Whatever the explanation, the paradox remains. How did the first great monument of civilization display the last word in precision? Every subsequent pyramid is worse, less aligned, less stable, less sophisticated. History should move the other way. Technologies evolve through trial and error, but at Giza, perfection appears first and declines after. That inversion suggests inheritance rather than invention. A monument built by a culture whose mastery was already ancient, whose knowledge of measurement and geometry came from a deeper lineage now lost. But precision alone does not explain the pyramid's strangest feature, the absence of light. Step inside the Great Pyramid and the sunlight dies instantly. The air turns cool and still. The walls swallow sound. Darkness folds around you like a second skin. You can feel the weight of millions of tons above your head, yet the silence is absolute. You reach out to trace the walls, perfectly straight, perfectly smooth. And then comes the question every visitor eventually whispers: how did they see in here? Because to carve this geometry in total darkness seems impossible. If torches or oil lamps had been used, the ceiling should be blackened with soot. Yet from the descending passage to the king's chamber, not a single smear of carbon residue exists. The limestone and granite are pristine, their pale surfaces untouched by smoke. Even microscopic analysis of the interior performed by the University of Cairo's Department of Archaeology confirms that the stone pores contain no trace of combustion byproducts, no unburned hydrocarbons, no lamp ash. This absence is so complete that it borders on eerie. Other tombs and temples from the Old and Middle Kingdoms show exactly what one would expect. Blackened ceilings, soot crusted into corners, scorch marks from years of flickering flame. The tomb of Seti I in the Valley of the Kings, for instance, is a gallery of soot-stained beauty, yet the Great Pyramid, supposedly built 1,000 years earlier, is immaculate. So if not flame, what brought light to the darkness? The traditional explanation is the mirror theory. That sunlight was reflected deep into the pyramid through a series of polished bronze mirrors. Egyptologists still repeat this idea, but physics disagrees. Even the best polished bronze reflects less than 40% of incident light. After just 3 or 4 reflections, the beam would lose nearly all its intensity, fading into nothing long before reaching the interior chambers. To test this, physicist Dr. John Baer of Oxford recreated a scaled mirror system in 2016. His experiment showed that by the 4th reflection, less than 3% of sunlight survived. The faint glow was insufficient to illuminate a worker's face, let alone the sharp chiseling required to smooth granite. Moreover, no archaeological trace of such mirror systems has ever been found. No mounting brackets, no polished discs, no fragments. The mirror theory, like torchlight, burns out quickly. Other hypotheses suggest the Egyptians used oil lamps with filtered wicks or fat-based fuels designed to burn cleanly, yet chemistry exposes another flaw. Even low smoke oils produce measurable soot over time. The longer a lamp burns, the more carbon accumulates. The Great Pyramid's untouched ceilings tell us that no open flame ever illuminated its passages. But what if the builders did not rely on fire at all? Deep within the Temple of Hathor at Dendera, over 400 kilometers south of Giza, lies a relief that has puzzled archaeologists for decades. It depicts priests holding what appear to be elongated bulbs, each containing a serpent-like form and connected by a cable to a box-like object. Some researchers interpret these as stylized symbols of creation, but others, including electrical engineer Eric Vonden, have suggested that the relief represents an ancient lighting device, what he called the Dendera light. When engineers built a physical model of the bulb using materials available in antiquity, quartz, copper, and acid electrolyte, it produced a faint glow similar to a low-voltage discharge tube. To mainstream science, this remains speculative, yet intriguing chemical residues inside the Dendera temple's crypt chambers show traces of zinc and sulfur compounds, the byproducts of galvanic reactions. Coincidence? Perhaps, but it hints at an ancient awareness of energy far beyond what textbooks allow. Now, consider the Great Pyramid's materials. Its core and inner chambers are constructed of Aswan granite, which contains high levels of quartz and feldspar, minerals with piezoelectric properties. When subjected to pressure or vibration, these crystals generate a small electrical charge. Surrounding that granite are the outer casing stones of white limestone, a strong electrical insulator. In modern engineering, this combination, an inner conductor wrapped in an insulating shell, forms a resonant cavity capable of concentrating and amplifying energy. Could the pyramid itself have functioned as a massive resonant structure, an energy transducer converting vibration into electricity or light? In 2018, physicists at ITMO University in St. Petersburg, working with the laser Zentrum Hanover, modeled how electromagnetic waves interact with the pyramid's shape. Their simulations revealed that at certain resonant frequencies, the internal chambers and the area beneath the pyramid's base concentrate electromagnetic energy in the core and foundation. The study, published in the Journal of Applied Physics, concluded that the geometry of the pyramid allows it to focus and amplify naturally occurring electromagnetic waves. This does not prove that it glowed like a light bulb, but it raises an intriguing possibility. Perhaps illumination was not provided by fire or reflection, but by resonance. The evidence is not limited to mathematics. When modern acoustic researchers tested the king's chamber, they found something extraordinary. It hums. At frequencies between 110 and 120 Hz, the granite walls begin to vibrate audibly. When that sound harmonizes with lower frequencies, especially around 8 Hz, the Schumann resonance of Earth's electromagnetic field, the entire chamber becomes a resonant cavity. In the darkness, the granite subtly glows under infrared cameras, heated not by flame, but by vibration. To the builders, this may not have been technology as we know it, but sacred physics. The harnessing of sound, energy, and geometry to create light, power, or even altered states of consciousness. Ancient Egyptian texts describe the gods as those who shone with light and refer to the priestly caste as keepers of the luminous flame that burns without smoke. These are poetic phrases, yes. But what if they preserve memory of something literal? Archaeologists have found other hints that Egypt's earliest temples were built for resonance rather than ritual. In the underground Serapeum of Saqqara, massive granite sarcophagi, each weighing up to 70 tons, resonate like tuning forks when struck. In the Osirian at Abydos, chambers carved directly into bedrock produce identical low-frequency vibrations. Acousticians call these standing waves. Ancient builders may have used them intentionally, amplifying sound and light in ways we barely comprehend. Some historians dismiss these findings as pseudoscience, yet they overlook one fact: the precision required to create such resonant spaces matches the precision of the pyramid's construction itself. Every angle, every chamber, every shaft seems tuned as if the entire structure were an instrument, not a tomb. When visitors today play a low tone inside the king's chamber, they often describe a tingling in their skin, a light-headed sensation, even flashes of brightness at the edge of vision. Some call it imagination, others call it induction. Either way, the experience suggests that the Great Pyramid interacts with the human body on frequencies we rarely sense. So perhaps the light of the pyramid was never visual, perhaps it was something deeper, an illumination of the mind, an awakening of perception triggered by resonance, a way to make those who entered see without seeing. Whatever its function, one thing is clear: the Great Pyramid was not built merely to house a corpse. Every measurement, every material, every chamber serves a physical and mathematical purpose, and if that purpose involved light, energy, or resonance, then we are not dealing with primitive builders. We are dealing with a civilization that understood the language of the earth itself. But if the Great Pyramid was not a tomb, and if it predates Khufu, then who built it, and when? To answer that, we must look not down at the stones, but up at the stars, because carved within the monument's dimensions and alignments is a message from a vanished world, a mathematical and astronomical code that still speaks across time. Under the desert moon, the Great Pyramid of Giza seems less a monument than a formula, a vast equation carved into the earth. Its angles rise with purpose. Its sides align with the stars. Its proportions whisper of balance and order. For those who study it closely, the stones begin to speak a different language. Mathematics, not the arithmetic of merchants or scribes, but something older and universal, the geometry of the cosmos itself. This, perhaps, is where the true mystery of the pyramid lies, not in how it was built, but in what it knows. Let us begin with a simple but astonishing fact. When modern engineers measured the pyramid's base and height, they discovered a ratio that seemed impossible for the time. If you take the perimeter of its base and divide it by twice its height, you get 3.1416, the value of pi, accurate to 4 decimal places. The same constant that defines the relationship between a circle's circumference and its diameter appears perfectly embedded in a structure made of straight lines and flat planes. But how could a Bronze Age culture have known pi so precisely? The earliest written approximation of pi, found in the Rind mathematical papyrus, dates to around 1650 BC, a full 1,000 years after Khufu. Even then, it was only an estimate 3.16. Yet the Great Pyramid, built long before that text, encodes the true value within its geometry. Coincidence? Unlikely, because pi is not the only constant hidden within the stones. The pyramid also embodies the golden ratio, phi 1.618, the same proportion found in spiral spirals of shells, petals of flowers, and the arms of galaxies. When you divide the slant height of the pyramid by half its base, the result is precisely phi. The structure fuses pi and phi, the mathematics of circle and line, infinity and form. To ancient builders, this was not merely clever geometry. It was theology in stone, the union of heaven and earth expressed through proportion. Archaeologists once assumed this precision was accidental, the byproduct of practical design, but satellite measurements have shown that these ratios recur throughout the complex. The smaller pyramids of Khafre and Menkaure follow similar harmonic relationships, scaled down as if by musical intervals. This harmony extends to the Sphinx, whose alignment complements the pyramid's geometry with eerie precision. The monument seems to have been laid out not as a building, but as a harmonic system. When researchers began to apply astronomical analysis to these ratios, the mystery deepened further. The Great Pyramid's latitude is 29.9792458 degrees north, a number that almost exactly matches the speed of light in meters per second, 299,792,458 meters per second. The precision is uncanny, a match to the 6th decimal place. Skeptics point out that the metric system did not exist in antiquity. True, but the alignment remains curious because latitude is a function of Earth itself, not human measurement. Whether the match is coincidence or a hint of ancient knowledge of geodesy, it adds another layer to the pyramid's cosmic precision. The monument is also oriented to true north with staggering accuracy, off by less than 3 arc minutes. That is almost 1/20th of a degree. To achieve that, the builders would have needed a method to measure precessional drift, the slow wobble of Earth's axis that changes the position of the celestial pole over thousands of years. Yet precession was not scientifically recognized until Hipparchus of Greece discovered it in 130 BC, over 2 millennia later. Even stranger, the pyramid's 4 sides are subtly concave, bowed inward by an average of 37 inches. This feature is invisible from the ground, only discernible from the air, as first noticed during a 1940 Royal Air Force survey. The concavity precisely matches the curvature of Earth's surface at Giza's latitude. In effect, the pyramid models both the shape and scale of the planet, implying an understanding of Earth as a sphere, knowledge not formally proven until 2,000 years later. Inside, the same mathematical language continues. The dimensions of the king's chamber, 10 cubits wide, 20 long and 11 high, form a perfect double square rectangle. This 1:2 ratio generates the frequencies associated with musical harmony. When sound is produced inside the chamber, the granite resonates at 440 and 432 Hz, tones that correspond to modern concert pitch and the so-called natural resonance of the earth. This is not coincidence. Ancient Egypt's temples, including Abydos and Dendera, exhibit similar resonant geometries. Stone-carved halls amplify specific frequencies, sometimes causing the entire structure to vibrate like a tuned instrument. The pyramid's designers understood that form and frequency are connected, that geometry can shape sound, and sound can shape consciousness. In 1998, acoustic engineer Tom Danley recorded standing waves inside the king's chamber that behave like those in a musical instrument. The chamber's resonance amplifies low tones, generating patterns of vibration that pulse through the stone itself. Modern imaging reveals interference nodes where the frequency builds, creating invisible fields of pressure. To the ancients, this might have been perceived as the voice of the gods, the living breath of the structure. The same harmony exists on a planetary scale. Multiply the pyramid's height by 43,200 and you get 6,357,000 meters, the exact polar radius of the Earth. Multiply its base perimeter by the same number and you get 40,030,000 meters, the planet's equatorial circumference. The odds of such precision by chance are astronomical. The number 43,200 is itself no accident. It is a multiple of 86,400, the number of seconds in a day. It encodes not just the size of the Earth, but the rhythm of its rotation. Whoever designed the pyramid did not simply build a monument, they built a scale model of our planet. To achieve this, they must have known both the circumference of the Earth and the concept of a spherical world, discoveries attributed to Eratosthenes in 240 BC, yet the pyramid predates him by more than 2,000 years. So did ancient Egyptians independently calculate these measurements? Or did they inherit this knowledge from a culture far older, one capable of mapping the globe with astronomical precision? The pyramid's geometry also encodes celestial cycles. The angle of its sides, 51 degrees 50 minutes, mirrors the angle of Earth's orbital tilt, 23.5 degrees from the plane of the ecliptic when doubled. Its alignment with Orion's belt and the star Sirius reflects the same sky visible around 10,500 BC, long before Egypt's dynasties began. The builders were not simply observing stars, they were documenting time on a scale of millennia, freezing the heavens in stone. Even the mathematical constants pi and phi have deeper symbolism. In sacred geometry, pi represents infinity, the circle with no beginning or end. Phi represents life, the generative proportion through which matter self-organizes. Together, they embody creation, the eternal and the living. The pyramid, then, can be read as a universal equation, life unfolding from eternity. This understanding appears in myths worldwide. The Mayan pyramid of Kukulkan at Chichen Itza encodes the solar year in its 365 steps. The temples of Angkor Wat in Cambodia align with precessional cycles spanning 25,920 years, the same great year known to ancient Egyptians. Across continents, the same constants, the same celestial ratios repeat, as if all these builders were reading from a single manual. The mathematics of the gods. Modern scientists call this coincidence, but coincidence begins to sound like language when it repeats with precision. If the Great Pyramid truly encodes the constants of the earth, the heavens, and the laws of vibration, then it is not merely architecture, it is data preserved through geometry, a message not written in ink but in proportion. And if so, it may be the oldest scientific document in human history, a stone record from a civilization that understood the universe as number, sound, and light, long before our own equations rediscovered the same truths. But the pyramid's message is not complete without looking upward to the pattern of stars that seem to mirror the Giza Plateau itself. For the constellation of Orion, etched across the sky, may not be an accident of myth, but a cosmic blueprint. The key to understanding when, and perhaps by whom, this pyramid was truly aligned. When night falls over the Giza Plateau, the desert becomes a sea of silence. the air cools. Stars spill across the black sky, countless points of light, ancient and eternal. From this height, standing before the Great Pyramid, the horizon seems to bend. The monument's apex points upward like a compass needle, and suddenly you begin to understand. This entire complex was not built merely for the earth, it was built for the heavens. For thousands of years, the Egyptians called their land Kemet, the Black Land, named for the fertile soil of the Nile, but they also called it Duat, the sacred land of the gods. To them, the sky was not a void. It was a mirror of the divine world, a celestial Nile flowing above the earthly one. And the Great Pyramid was the meeting point, the axis where heaven and earth touched. In 1993, engineer and researcher Robert Bauval made an observation that changed how we see Giza forever. Studying aerial photographs of the pyramids, he noticed something peculiar. The three pyramids were not arranged in a perfect line, as most assumed. The smallest, that of Menkaure, was offset slightly to the south. It was a detail few had questioned, until Bauval realized that the same offset appears in the three stars of Orion's belt: Alnitak, Alnilam, Mintaka. When he overlaid the map of Orion onto the pyramid plan, the alignment was nearly perfect. The relative positions and sizes matched. The largest star to the largest pyramid, the smallest to the smallest. Even the offset direction corresponded. The Giza Plateau, it seemed, was not random architecture, but a celestial reflection. A map of Orion laid onto the sands of Egypt. But Bauval's discovery did not stop there. Using astronomical software, he calculated the position of Orion's belt across millennia, adjusting for axial precession, the slow wobble of Earth's rotation that shifts the apparent position of the stars over time. When the stars of Orion were aligned precisely with the pyramids, the clock of heaven pointed to 10,500 BC. That date does not just fall outside Khufu's reign, it precedes Egypt itself. It lands near the end of the Younger Dryas, a period of global cataclysm, massive flooding, abrupt climate shifts, the extinction of Ice Age megafauna. It is also the same era when other mysterious monuments, Göbekli Tepe in Turkey, the Sphinx's eroded body, and ancient flood layers in Mesopotamia seem to converge. Could the builders of Giza have been commemorating an earlier sky? A celestial memory of a world destroyed. Mainstream scholars resisted Bauval's conclusions, arguing that the alignment was coincidence. Yet the coincidences multiplied. The pyramid's relative brightness matches that of Orion's belt. Khufu's pyramid corresponds to the brightest star, Alnitak, Khafra's to Alnilam, Menkaure's to Mintaka, the faintest. Their layout mirrors not only Orion but its declination angle relative to the Milky Way. When viewed from above, the Nile runs across Giza exactly as the Milky Way does across Orion in the ancient sky, a celestial river reflected on Earth. The Egyptians themselves called the Milky Way the winding waterway of the gods. The dead were believed to sail along it after death, guided by the constellation Sar, the divine name for Orion, toward eternal life. In this cosmic mythology, Orion represented Osiris, god of rebirth, while the bright star Sirius nearby symbolized his consort, Isis. Each year, Sirius's rising before dawn heralded the flooding of the Nile, the rebirth of Egypt itself. Now look again at the pyramid shafts. The southern shaft from the king's chamber points directly to Orion's belt, the northern shaft to the pole star Thuban. Meanwhile, the queen's chamber's southern shaft targets Sirius, and its northern one points to Kochub in Ursa Minor, These alignments are not random tunnels, they are cosmic sight lines connecting the earthly realm of kings to the heavens of gods. To the Egyptians, this was not architecture, it was resurrection technology. The pharaoh's spirit, upon death, was believed to ascend through these shafts, travelling along beams of starlight toward Orion, the realm of Osiris, where he would be reborn among the stars. The pyramid itself was a machine for immortality. But the precision of these alignments suggests that whoever designed them understood the sky not as priests or poets, but as astronomers. They had to measure stellar declinations with an accuracy of less than 1 arc-minute, a feat requiring instruments that would not reappear until the Renaissance. They also had to account for precession, a phenomenon invisible to a single lifetime, taking 26,000 years to complete one cycle. So how could a civilization supposedly born in 3000 BC have encoded a sky from 10,500 BC? A pattern visible only at the end of the Ice Age. Either they possessed knowledge inherited from an older world, or the pyramids themselves were built in that earlier age, preserving a snapshot of the heavens that once shone above a different Earth. Evidence for that inheritance lingers in myth. In Egyptian cosmology, Zep Tepi, the first time, marked the era when the gods descended from the stars to establish order after a cosmic flood. Osiris ruled the earth, teaching mankind civilization until disaster struck and he was slain by his brother Set. Isis resurrected him briefly, conceiving their son Horus, who later avenged his father and restored the divine order. To Egypt's priests, the rising of Orion each year symbolized that same resurrection, a story of destruction and renewal written in the stars themselves. Could the myth of Osiris encode memory of a real event, a cataclysm that destroyed a primordial civilization whose survivors rebuilt along the Nile? If so, the Giza complex might not just imitate the heavens, it might commemorate them, a cosmic memorial to the world before the flood. Astronomical modelling strengthens the link. When the Orion alignment at Giza peaked around 10,500 BC, the constellation Leo rose due east, directly where the Sphinx faces. The lion-bodied statue, weathered by ancient rains, may symbolize the age of Leo, the same epoch when Orion's alignment was perfect. Together, the Sphinx and the pyramids mark a celestial timestamp, a double signature of time and myth. Across the world, similar patterns appear. The temples of Teotihuacan in Mexico align with Orion's belt. The complex's central avenue mirrors the Milky Way. The megaliths of Nabta Playa in southern Egypt, dated to around 6000 BC, align with both Orion and Sirius, thousands of years before Khufu. Ancient builders everywhere seem to have looked up and built down, mapping heaven onto earth. Were these parallel evolutions, or the echoes of a single global knowledge system? A prehistoric science of the sky that predated recorded history? Even modern astronomy cannot fully dismiss the precision of Giza's stellar design. When NASA physicists mapped the pyramid's coordinates against Earth's axial tilt and the orbital plane of Orion, they found geometric relationships that repeat at scales of both planetary and galactic proportion, as if the builders had encoded not only where they were, but when they were. Whatever the explanation, one truth remains. The Great Pyramid is not a tomb frozen in stone. It is a clock, one that measures epochs, not years. Its geometry and alignments trace the turning of the heavens across millennia. And if it does point back to 10,500 BC, it may hold the memory of a lost chapter in human history. A civilization wiped from the surface but not from the stars. But if the pyramid was not built by the Egyptians, if it predates their civilization by thousands of years, then what happened to its true builders? And why would they construct such a monument? To answer that, we must step beyond archaeology, beyond even astronomy, and into the realm of myth and memory. Because scattered across the planet are stories of a world that ended in flood and fire. Ancient myths scattered across continents seem to remember fragments of one great undoing, a cataclysm that drowned the world and buried its memory in mud and ice. Plato wrote of Atlantis, an island empire destroyed in a single day and night of misfortune. Around 11,600 years ago, the same epoch geologists now associate with the Younger Dryas, when a sudden global melt flooded continents and reset climate and civilization alike. Egyptian priests told Plato that their ancestors had only inherited fragments of a far older world, a world destroyed by fire and flood. They called its survivors the Shemsu Hor, the followers of Horus, semi-divine beings who ruled before the first dynasties. Their memory was mythologized as gods walking among men, teaching writing, architecture, and the ordering of the heavens. To the Egyptians, the Great Pyramid and the Sphinx were not beginnings, they were reminders. If that sounds like legend, the Earth itself seems to agree. Around 12,800 years ago, Greenland ice cores record a massive spike in platinum, a chemical signature of a cosmic impact. Nanodiamonds, glass spherules and melt layers appear in strata from North America to the Middle East, evidence of a global catastrophe. Sea levels rose more than 120 meters in a geological blink. Entire coastlines vanished. What would survive such a reset? Not cities, not libraries, but perhaps stone. If a civilization existed before that event, call it Atlantis or something nameless, then its survivors would have migrated to regions spared from the worst floods. Uplands, river deltas, the fertile plains of the Nile. There they might have preserved fragments of lost knowledge, astronomy, geometry, resonance, and rebuilt what they could, encoding their science in monuments too durable to erase. The Great Pyramid, in that view, is not a tomb or even a temple. It is a message across epochs. A monument built not to glorify a king, but to preserve the memory of a civilization erased by time. The numbers begin to align. The date of the Orion correlation, 10,500 BC. The end of the Younger Dryas, 9,600 BC. The emergence of advanced sites like Göbekli Tepe in Anatolia, suddenly appearing with megalithic architecture and celestial alignments. These are not isolated sparks of genius, but embers of a forgotten fire. The same blueprint rising again in scattered hands. Perhaps the builders of the Great Pyramid were the inheritors of that fire, refugees of a cataclysm who encoded their world's knowledge in indestructible form. The limestone shell symbolizes the earth, the granite core, energy, the ascending shafts, the path of the soul, geometry as language, proportion as memory. Everything they knew, mathematics, astronomy, time, folded into one timeless structure. And maybe they knew it would not be understood. Maybe that was the point. The pyramid was not built for the people of its own time. It was built for whoever would rediscover it after the next cycle of destruction. A cosmic archive. A seed for civilization's rebirth. The idea of cycles runs through every ancient culture. The Hindus speak of yugas, repeating ages of rise and fall. The Mayans described 5 suns, each world destroyed and remade. The Egyptians themselves believed in a recurring flood of Nun, the primordial waters that reset creation. Even modern science now recognizes Earth's pattern of cataclysms every 12,000 years. Sudden shifts in climate, magnetic reversals, impact winters. If the Great Pyramid dates to the last such turning around 12,000 years ago, then its builders may have known what we are only rediscovering. That civilization is not a straight line, but a circle. We rise, we fall, we forget, and we begin again. Maybe that is why the pyramid endures, not as proof of one lost civilization, but as the heartbeat of many, a pulse of memory across ages. Its silence is deliberate, its perfection is a language we have only begun to read. And what of the voids discovered inside, the tunnels below? Perhaps they hold more than air and sand. Perhaps they hold a record waiting to awaken, not in words, but in resonance. A frequency that one day, when rediscovered, will vibrate again and speak the story of the first time. For now, the monument waits. Each dawn, sunlight climbs its face exactly as it has for millennia, tracing the same lines, igniting the same stone. The earth turns, the stars shift, the ages pass, but the pyramid does not move. It is the needle that stays still while time spins around it. Beneath the sand, beneath the tourist trails and the chatter of cameras lies another Egypt, one the public never sees. Down there, in the dark underbelly of the Giza Plateau, stone gives way to silence. The wind dies, light fades, and the weight of history presses down like the very rock that hides it. For centuries, explorers believed the Great Pyramid stood alone, isolated and self-contained. But modern technology has begun to reveal something astonishing. The pyramid is only the surface of a much larger mystery. An ancient network buried deep beneath the ground. It began, as so many revelations do, not with a shovel, but with a particle. In 2015, a group of scientists from Cairo University and Nagoya University in Japan launched the Scan Pyramids project, an ambitious attempt to peer inside Egypt's monuments using muon tomography, a form of cosmic ray imaging. Unlike radar or ultrasound, muon scans detect subatomic particles that constantly rain down from space, passing through rock and registering subtle density differences. It is the same technique physicists use to examine the interior of volcanoes and nuclear reactors. For nearly 2 years, detectors placed in the pyramid's chambers and around its base silently collected data. When the results were finally processed, they revealed something no one expected, a massive hidden void above the Grand Gallery. It was not a crack or a cavity. It was a deliberate structure, at least 30 meters long, centered within the pyramid's core. The data were clear. This was not a flaw in the stone, but a chamber. A space deliberately carved and sealed thousands of years ago. When the findings were published in the journal Nature in 2017, the Egyptological world erupted. Was this the lost burial chamber of Khufu, a construction gap, or something far older? The team called it the Big Void, careful not to speculate, but others were less cautious. Some noted that the chamber's position mirrors the Grand Gallery below, as if forming a symmetrical pair. Perhaps an architectural resonance chamber. Others pointed to legends of hidden archives buried within the Great Pyramid. Records from a forgotten epoch. Egypt's Ministry of Antiquities responded with silence, then restriction. Requests for drilling or further exploration were denied. The official explanation was preservation of the structure. The unofficial one was preservation of the narrative. Since then, new data have only deepened the mystery. In 2023, an updated Muon scan revealed a narrow corridor roughly 9 meters long, concealed behind the northern face of the pyramid above the original entrance. Three-dimensional modeling showed that it leads to an enclosed cavity, potentially intersecting with other larger voids deeper inside. Endoscopic cameras inserted through micro-bore holes captured images of smooth limestone walls untouched by human hands for thousands of years. There were no inscriptions, no tools, no evidence of plunder, just emptiness, pristine and deliberate. Simultaneously, ground-penetrating radar surveys around the base of the pyramid detected a series of linear anomalies, patterns inconsistent with natural geology. These were not random fractures, but structured voids forming grid-like corridors stretching beneath the plateau. Further afield between the pyramid and the Sphinx, researchers mapped irregular low-density zones extending downward more than 40 meters. Some form perfect right angles. Others connect to known tomb shafts, but continue far beyond their documented limits. Could these be natural fissures? Possibly. But beneath Giza, natural rarely applies. History itself hints that these discoveries are not new. The Greek historian Herodotus, visiting Egypt in the 5th century BC, wrote of underground passages and a subterranean lake beneath the pyramid, where the body of Khufu supposedly rested on an island. For centuries, scholars dismissed this as myth. Yet modern surveys have confirmed the presence of large cavities filled with moisture, ancient groundwater sealed in stone for millennia, directly beneath the pyramid's foundation. In 1837, Colonel Howard Vyse, the same man who found Khufu's cartouche, blasted into a deep pit below the Great Pyramid's descending corridor. He discovered a rough chamber he called the subterranean room. Carved directly into the bedrock, it resembles a half-finished tomb, but one with no sign of burial, no sarcophagus, no inscriptions. Some engineers now believe it predates the pyramid itself, possibly the remnant of an earlier structure or a core excavation reused by later builders. French archaeologist Auguste Mariette, exploring the area in the 1850s, described tunnels as endless as they are ancient, leading away from the Sphinx toward the Nile. In the 20th century, British explorer Howard Vyse's notes mentioned unexplained airflow near sealed doorways, suggesting interconnected chambers below. These clues persisted but were ignored, overshadowed by the grandeur above ground. Modern geology adds another layer to the puzzle. Core samples taken from around Giza reveal thick deposits of Nile silt between bedrock layers, suggesting that the plateau experienced massive flooding long before the dynastic era. The last time the Nile reached that height was during the Younger Dryas, around 11,000 to 12,000 years ago. The same epoch linked to global cataclysmic floods. If structures existed beneath the surface then, they could have been buried, preserved under sediment, and later rediscovered by Egypt's early dynasties. This is not speculation alone. In 1992, seismic studies conducted by geophysicist Thomas DeBecke and archaeologist John Anthony West near the Sphinx revealed cavities beneath its left paw. Rectangular, symmetrical, unmistakably artificial, Egyptian officials quickly sealed off further exploration. When reporters pressed for comment, the response was curt. No further investigation planned. To this day, those voids remain unexamined. So what are these hidden networks beneath Giza? Storage chambers, construction ramps, or something older, something that predates even the earliest kings? Some researchers believe the underground passages once formed a ceremonial complex where priests reenacted the pharaoh's journey through the underworld. Others, more daringly, suggest they are remnants of a pre-dynastic knowledge archive. The fabled Hall of Records, described by both ancient Egyptian legends and later mystics like Edgar Cayce. Cayce's claim, dismissed by academia, described a hidden library buried between the pores of the Sphinx containing records from Atlantis, preserved against a global flood. While this story remains unproven, it is worth noting that radar imaging has indeed confirmed a large cavity beneath that very spot, sealed and untouched. Whether or not it holds Atlantean records, something is undeniably there, and perhaps that is the larger point. Every new scan, every new survey keeps confirming the same thing. The Giza Plateau is hollow, threaded with passageways and voids that defy our assumption of simple pyramid on bedrock construction. The ancient builders did not just raise monuments, they built into the earth itself. If the Great Pyramid is the tip of a buried iceberg, then its true story lies below. The corridors beneath may be older than the pyramid stones, dating back to a civilization erased by flood or time. Perhaps the pharaohs of Egypt found these ancient catacombs already in place and built above them, claiming their legacy as their own. Imagine for a moment, under every step you take on the plateau, tunnels stretch into darkness, their walls carved with forgotten symbols, their chambers sealed since the dawn of history. They wait, perfectly preserved, like the hard drives of an ancient world. And maybe, just maybe, somewhere in that darkness lies the final piece of the puzzle. Proof that the Great Pyramid was not the work of the Egyptians alone, but a gift or inheritance from a civilization far older than we have ever dared to imagine. But even beyond the tunnels, beyond the hidden chambers and sealed voids, there is another question that haunts the monument. A question that archaeologists have struggled to answer for generations. If the Great Pyramid was not a tomb, then what was its purpose? Step into the king's chamber and the world outside dissolves. The air is heavy, metallic, still. The granite blocks press inward with a weight you can feel in your bones. There are no paintings, no carvings, no inscriptions, nothing that identifies the room as the resting place of a pharaoh. Only a rectangular granite box sits near the western wall. Lidless and hollow, like an echo waiting for a voice. This is supposed to be Khufu's tomb, the culmination of Egypt's most ambitious monument. Yet where other royal chambers overflow with hieroglyphs, gold, and ritual texts, this one is naked. Its silence feels intentional, almost defiant. Archaeologists call it austerity, others call it amnesia. But perhaps it is something else entirely. Let us start with the obvious contradiction. No human remains have ever been found inside the Great Pyramid. Not a bone, not a fragment of coffin, not even resin from mummification. The granite box, often called the sarcophagus, is empty, and its interior shows no sign of ever holding a body. The box itself is too large to fit through the narrow passageways, meaning it had to be placed there during construction, long before the pyramid was sealed. But if it was made for a royal burial, why install it before the mummy existed? And why leave no lid, no inscriptions, no offerings? Compare this to the tomb of Tutankhamun, discovered untouched in 1922. Walls covered in sacred text, rooms packed with 5,000 artifacts, the air still thick with the scent of oils after 3,000 years. That is what a pharaoh's tomb looks like. The Great Pyramid, by contrast, feels less like a burial and more like a chamber of calculation. The deeper you examine its architecture, the more the tomb theory collapses. The internal passages form a layout unlike any known Egyptian burial. The grand gallery rises with the symmetry of a machine housing, its corbelled walls tapering upward as though designed to channel or contain force. Above the king's chamber, 5 relieving chambers distribute pressure through interlocking granite beams. An extraordinary feat of load management. For a simple tomb, such engineering is absurdly excessive. It is like constructing a nuclear reactor to protect a single coffin. Then there is the acoustics. Sound behaves strangely here. A low hum set off inside the king's chamber reverberates through the granite until your chest vibrates with it. At 440 Hz, the modern musical the chamber resonates naturally, but at 432 Hz, that resonance becomes profound, generating standing waves that travel the length of the structure. Microphone tests reveal harmonic frequencies that match those of the Earth's natural vibration, the Schumann resonance. Again, it is as though the chamber was tuned to the planet itself. When physicist Tom Danley performed sonic mapping in 1998, he found that the chamber amplifies frequencies between 90 and 120 Hz, a range associated with low vibrational states that affect human perception. People inside often describe feeling a sense of expansion, disorientation, even altered consciousness. Whether psychological or physical, the effect is real. Was this deliberate? If so, the pyramid may have functioned as a kind of resonant temple, designed not for the dead, but for the living, a space where sound, vibration, and geometry merged to induce states of transformation. The Egyptians believed the soul, or ka, could travel between worlds through harmonics of sound. Priests chanted in specific tones, believing these frequencies opened pathways to the divine. Could the Great Pyramid have been the ultimate instrument of that belief? An acoustic gateway? Recent ground-penetrating radar surveys show even more complexity. Beneath the king's chamber lies the so-called subterranean chamber, an unfinished cavity deep below the pyramid cut directly into bedrock. It is oddly shaped, asymmetrical, and seems to serve no burial purpose. Some speculate it was part of a resonance system, a counter-chamber to balance vibrations above. Others think it is older than the pyramid itself, a remnant of an earlier phase or structure upon which the later builders expanded. The idea grows stranger when you recall the materials. The pyramid's interior granite, rich in quartz, behaves like a resonant crystal. When subjected to sound or pressure, quartz produces an electrical response. Piezoelectricity, combine millions of tons of it in geometric harmony, and you have something that behaves less like a tomb and more like a massive energy transducer, converting sound and vibration into subtle electrical charge. Could this be why the interior shows no soot? Why no lamps were needed? Some have theorized that the resonance itself produced luminous phenomena. Faint plasma discharges or piezoelectric glow illuminating the chambers with natural light. We may never prove this conclusively, but it suggests that the pyramid's emptiness is not neglect, it is design. The absence of ornament was not a lack of faith, but the opposite, a belief that divinity could be expressed in precision alone. To those who built it, symmetry was sacred scripture. But this perspective raises an even larger paradox. If the Great Pyramid was not a tomb, then what was its purpose? And if it was not Khufu's engineers who tuned this instrument of stone to the heartbeat of the earth, then who were they? The answer may lie in examining not just what the Egyptians built, but what they inherited. When we walk through the grand halls of Egyptian museums, every statue and stela bears a familiar pattern, rows of hieroglyphs declaring who built what, who ruled, who conquered. Names carved deep into stone as if to anchor themselves against time. Yet if you look closely, you will see something odd. Many of those names have been carved over others. Beneath Ramesses, another faint script. Beneath Seti, another cartouche half erased. The Egyptians were masters not only of construction but of appropriation. They did not just build monuments, they inherited them and rewrote them. This practice had a name, usurpation. In modern language, it means to take by force, but to an ancient Egyptian, it meant continuity. A pharaoh stepping into the power of his divine predecessors. To carve over an older name was not desecration, but sanctification. Yet through this ritual rewriting, truth itself became blurred. Temples, statues, even gods were rebranded. Over centuries, one dynasty after another polished out the past and etched in its own reflection. Nowhere is this clearer than in the reign of Ramesses II, known as Ramesses the Great, the builder pharaoh. His likeness dominates Egypt. Colossal seated statues, temples rising from cliffs, inscriptions celebrating him as the architect of all wonders. But archaeology tells a quieter story. Ramesses built much, yes, but he also claimed more than he constructed. At Abydos, Ramesses' inscriptions sit atop the reliefs of his father, Seti I, chisels having scraped away older hieroglyphs. At Luxor Temple, his cartouches appear over those of Amenhotep III, whose massive statues Ramesses simply renamed. Even the great temple of Abu Simbel, attributed entirely to Ramesses, shows signs of modification rather than original creation. The stonework beneath the newer reliefs is eroded, ancient even in his time. The pharaoh who sought eternal fame may have achieved it by stamping his identity over the memory of those who came before. If usurpation was common practice during Egypt's later dynasties, could it also have happened in the 4th dynasty? Or before? Let us return to the Great Pyramid. The single piece of proof connecting it to Pharaoh Khufu is that red cartouche found by Howard Vyse, painted in haste, misspelled and suspiciously modern. Outside those few marks, not a single inscription anywhere names Khufu as the builder. No temple reliefs show his workers hauling limestone. No papyrus describes the construction. No statue commemorates the achievement. For the greatest architectural project in human history, there is silence. Meanwhile, the smaller pyramids nearby, supposedly built later, do carry inscriptions, even decorative chambers filled with texts and art. The oldest and largest, paradoxically, is also the most anonymous. Archaeology offers another clue. The recycling of monuments across Egypt. Entire temples were rebranded. The Step Pyramid of Djoser at Saqqara, hailed as the first pyramid, was expanded and modified by later kings. Its core structures, however, predate Djoser himself. The Osirian at Abydos, a massive subterranean complex carved from granite blocks, lies 20 feet below Seti Uman's temple and shows water erosion far older than his reign. Seti's builders simply incorporated it, carving hieroglyphs on the already ancient walls and claiming it as their own. Even in the shadow of the Sphinx, evidence suggests layered ownership. Restoration inscriptions from Thutmose IV describe him awakening the monument from the sand after it had lain buried since the time of the ancestors. His dream. Stahler makes no claim of building the Sphinx, only of rediscovering it. He calls it Horem Akhet, the becoming of the sun, as though the statue already held divine significance long before his time. To archaeologists, this is not scandalous. It is standard practice. Dynasties inherited, renovated, repurposed. But when applied to the Great Pyramid, the implications are staggering. If Khufu merely refurbished or re-sanctified an existing monument, adding his name, his mortuary temple, and his royal causeway, then the pyramid could be thousands of years older than his reign. Its original builders, whoever they were, had long vanished. Egyptian priestly texts hint at such a scenario. The ancient chronologist Manetho, writing in the 3rd century BC, described Egypt's history as a sequence of ages, the reigns of gods, demigods, and finally mortal kings. The divine rulers, the Shemsu Hor, or followers of Horus, reigned for thousands of years before Menes unified Egypt around 3100 BC. To the priests of Heliopolis, this earlier epoch was known as Zep Tepi, the first time, an age when gods walked the earth and built sacred structures aligned with the heavens. Modern Egyptologists label Zep Tepi as myth, yet myths often encode memory. In Sumer, similar stories speak of kings who ruled for tens of millennia before the flood. In India, the Sanskrit texts describe previous yugas, cycles of rise and collapse long before our recorded age. The consistency of these traditions suggests that the idea of a first civilization was not fantasy but ancestral recollection. And so we face a provocative question. Was Khufu's Egypt the inheritor, not the inventor, of the pyramid tradition? Consider how later Egyptians treated the Great Pyramid. For them, it was not a tomb, but a temple of mystery. During the Greek and Roman periods, priests and scholars entered its chambers seeking divine knowledge. They called it the Pillar of Enoch, or the Sanctuary of Thoth. Islamic chroniclers later referred to it as a repository of ancient wisdom built before the flood. Even the 10th century historian al-Makrizi wrote that the pyramids were constructed by a pre-dynastic king to preserve knowledge from a coming cataclysm. Each generation, it seems, layered its own interpretation upon the monument, rewriting not just who built it, but what it meant. The pharaohs carved their names. The Greeks turned it into philosophy, the Arabs into legend. In each retelling, the true builders slipped further into shadow. The irony is that modern archaeology continues the same tradition. We too rewrite the past to fit our comfort. We accept vice's painted proof, ignore anomalies that do not align, and declare the mystery solved because it must be. To admit uncertainty is to unmoor history itself, but the stones do not lie. Their precision, their erosion, their silent geometry all point toward an origin beyond Khufu's time. The Great Pyramid is not an isolated marvel of Egyptian ambition. It is the echo of something older, the blueprint of a forgotten age, rebranded by those who came later. If Khufu was not the builder, then who was? And what knowledge did that earlier civilization possess to shape stone with such impossible mastery? To answer that, we must look not at what the pyramid contains, but at what it represents. A structure that bridges earth and sky, past and future, memory and eternity. The more we study the Great Pyramid, the more it reveals itself not as a single monument, but as a convergence point. A place where multiple timelines, multiple civilizations, and multiple purposes intersect. It is as if the structure was designed in layers, each era adding its meaning while preserving something far older beneath. Consider the sheer diversity of what the pyramid encodes: mathematical constants, astronomical alignments, geodetic measurements, acoustic properties, energy transduction. No single culture, no single generation could have conceived all of this simultaneously. It is too comprehensive, too multifaceted, unless, of course, it was not conceived by a single culture at all. What if the Great Pyramid is a palimpsest, a manuscript written over and over across millennia, each layer of meaning preserved beneath the next? The core structure, perhaps 12,000 years old or more, built by survivors of a cataclysmic event. A civilization that understood the Earth was not flat but spherical, that knew the planet's dimensions with precision we would not match until the age of satellites. That mapped the stars not just for navigation but for something deeper, a cosmic calendar tracking the great cycles of time. Then came the floods, the climate shifts, the collapse, but the monument endured. Buried under sand and silt, it waited. When the Sahara dried and new peoples migrated to the Nile Valley, they found it, already ancient, already weathered, already silent. These early Egyptians, the people of the pre-dynastic period around 4000 to 3000 BC, did not build the pyramid. They rediscovered it. To them, it was a relic of the gods. A structure from Zep Tepi, the first time. They may have cleared the sand, repaired damaged casing stones, built temples around its base, but they did not understand its full purpose any more than we do today. By the time of the 4th dynasty, around 2600 BC, Egypt had become a centralized kingdom. Pharaohs sought to legitimize their divine rule by connecting themselves to the ancient past. Khufu, or whoever ruled at that time, did what rulers have always done. He claimed the monument as his own. Perhaps he added the mortuary temple. Perhaps he installed the granite box in the king's chamber, repurposing an ancient resonance chamber as a symbolic tomb. Perhaps he commissioned Vise's predecessor, some ancient forger, to paint his name inside. Or perhaps Vise did that himself millennia later, when the truth had already been lost. Either way, the pyramid became Khufu's, not through construction, but through appropriation. And the textbooks, written by people who needed neat answers, accepted that appropriation as fact. But the evidence keeps pushing back. The water erosion that predates Egypt's desertification, the carbon dating that refuses to align, the precision that exceeds Bronze Age capabilities, the empty chambers that suggest function over burial, the astronomical alignments that point to 10,500 BC, the geometric encoding of Earth's dimensions. All of it whispers the same message. This structure is older than Egypt, older than writing, older than recorded history. It belongs to a chapter of human civilization we have forgotten, or perhaps been taught to forget. Because if we accept that the Great Pyramid predates the Egyptians, then we must accept something even more unsettling. That advanced civilization is not a recent development, that our ancestors were not primitive, that history is not a straight line from caves to cities, but a cycle, rising and falling, building and forgetting, remembering and losing again. The implications are staggering. Every textbook would need revision, every timeline reconsidered, the entire narrative of human progress. The story we tell ourselves about who we are and where we came from would collapse, and perhaps that is why the resistance is so fierce. Not because the evidence is lacking, but because the truth is too destabilizing to accept. Yet the truth persists in stone, in the 6.5 million tons of limestone and granite that have stood for millennia, indifferent to our theories. The Great Pyramid does not care what we believe, it simply is. And it will outlast our debates, our denials, our desperate attempts to fit it into a comfortable narrative. One day, perhaps centuries from now, when our own civilization has risen higher or fallen lower, someone will stand before the pyramid again. And they will ask the same questions we ask now. Who built this? When? And why? Maybe by then, we will have developed the technology to explore those hidden chambers, to map the tunnels beneath Giza completely, to analyze every stone with instruments we have not yet invented. Or maybe the answers are already there, waiting in plain sight, encoded in the mathematics we have already measured, the astronomy we have already charted, the resonance we have already felt but not understood. The ancient world was not primitive, it was different. Its knowledge took forms we no longer recognize. Where we see religion, they saw science. Where we see myth, they encoded history. Where we see monuments, they built machines. Not machines of gears and circuits, but machines of stone and sound. Structures that interacted with the Earth's natural frequencies. Buildings that functioned as instruments, as calendars, as energy concentrators, as resurrection devices. The Great Pyramid may have been all of these things, a multi-purpose structure designed to serve the living and the dead, to mark time and preserve knowledge, to connect earth and sky, to survive the next cataclysm and speak to whoever came after. And here we are, the ones who came after, standing in the shadow of something we built, or our ancestors built, or someone built so long ago that the memory has become myth. We have the technology now to ask better questions. Moon tomography, ground-penetrating radar, laser scanning, chemical analysis, acoustic mapping. Each new tool reveals another layer of the mystery. But tools alone are not enough. We also need the courage to question our assumptions, to look at the evidence without the filter of what we have been taught to believe, to say, "I do not know," instead of clinging to convenient explanations that do not fit the facts. The greatest obstacle to understanding the Great Pyramid is not lack of evidence, it is an abundance of certainty. Certainty that we know how it was built, certainty that we know when it was built, certainty that we know who built it, certainty that Bronze Age Egyptians with copper tools and wooden ramps accomplished what we could barely replicate today with modern machinery. That certainty is not based on evidence. It is based on assumption, on the need for history to make sense, on the comfort of believing that civilization progresses in a straight line, ever upward, never back. But what if history does not work that way? What if civilizations rise and fall like waves, each one building higher than the last, then crashing down, leaving only fragments for the next wave to find and puzzle over? The Great Pyramid may be such a fragment, the peak of a wave that rose 12,000 years ago and crashed in the Younger Dryas floods. What survived was not the civilization itself, but its greatest achievement, a monument built to outlast the deluge, a time capsule in stone. And we are the next wave, slowly rising, slowly rediscovering what was once known and lost. If that is true, then the Great Pyramid is not just a mystery. It is a mirror. It shows us what we could become and what we could lose. It reminds us that knowledge is fragile, that civilizations are temporary, that the only way to preserve understanding across deep time is to encode it in something that cannot be destroyed. Stone, mathematics, geometry, astronomy, the universal languages that transcend culture and era. Perhaps that is the pyramid's ultimate message. Not "look what we built," but "remember what you knew." Not a boast, but a warning. Not a tomb, but a beacon, calling across thousands of years to anyone with eyes to see and minds to understand. We have been here before. We knew these things. We built this to remind you. Do not forget again. And as the sun sets over Giza once more, the Great Pyramid catches the last light. For a moment, its weathered surface glows gold, the way it might have glowed when it was covered in polished white limestone, when it shone like a second sun, visible for miles across the desert. That vision is lost to us now. The casing stones were stripped away centuries ago, repurposed for mosques and palaces in Cairo. But the core remains, massive, silent, eternal. A riddle waiting for us to ask the right questions. The tourists have gone home, the vendors have packed up, the plateau returns to stillness. And in that stillness, if you listen carefully, you can almost hear it, the hum of the earth itself, the resonance that the ancient builders tuned this structure to amplify. The frequency that connects stone and star, matter and energy, past and future. The Great Pyramid stands at the center of it all. Not the center of Egypt, though it marks that too, but the center of a mystery that spans the entire arc of human history. From the forgotten civilizations of the deep past to the uncertain civilizations of the future, it is a monument that belongs to no one and everyone, to the ones who built it, whoever they were, to the Egyptians who inherited it, to the explorers who rediscovered it, to the scientists who study it, and to you reading these words, asking the same questions humans have asked for thousands of years. The question lingers in the desert air like the dust that never quite settles. Who were we before we forgot? It is a question that extends beyond the Great Pyramid, beyond Egypt, beyond any single monument or civilization. Because the more we examine the ancient world, the more we find evidence of knowledge that should not exist. Knowledge that contradicts the neat timeline we have constructed for human development. Consider the Antikythera mechanism discovered in a Roman shipwreck off the coast of Greece. A device so sophisticated, so precisely engineered that when it was first X-rayed, scientists thought it was a modern contamination. An ancient Greek computer built around 100 BC capable of predicting astronomical positions and eclipses decades in advance. The level of miniaturization and gear cutting required would not be seen again until the 14th century. How did they know? How did they build it? And what else did they know that we have lost? Consider the megalithic structures scattered across the globe. Baalbek in Lebanon, with its foundation stones weighing up to 1,200 tons. Stones so massive that even today we do not have cranes capable of lifting them. Yet, somehow, thousands of years ago they were quarried, transported and placed with such precision that a knife blade cannot fit between the joints. Sacsayhuaman in Peru, where massive boulders are fitted together in complex polygonal patterns, each stone shaped to match its neighbours with mathematical exactitude. No mortar, No gaps, just stone meeting stone with a perfection that seems to defy the limitations of ancient technology. Göbekli Tepe in Turkey, dated to 9600 BC, older than agriculture itself. A massive temple complex built by people who supposedly lived in small hunter-gatherer bands, who supposedly had not yet invented farming, writing, or cities. Yet, they carved pillars from bedrock, some weighing 20 tons, decorated them with sophisticated reliefs of animals, and arranged them in precise circular formations aligned to celestial events. The conventional timeline of human civilization says this is impossible. Hunter-gatherers do not build monuments. They do not organize large-scale labor projects. They do not possess the mathematical knowledge required for astronomical alignments. Yet there it stands, pushing the origins of monumental architecture back nearly 12,000 years. Right to the end of the last ice age. Right to the time when the Great Pyramid's Orion correlation points. These are not isolated anomalies. They are pieces of a larger puzzle, a puzzle that suggests human civilization is far older than we acknowledge, that the rise from primitive to advanced did not happen once in Mesopotamia around 3000 BC, but multiple times across deep history. And that some of those earlier rises reached heights we are only now beginning to understand. The problem is evidence, or rather, the lack of it, because if advanced civilizations existed 10,000 or 12,000 or 15,000 years ago, where are their cities? Where are their tools? Where are their written records? The answer may be simpler than we think: underwater. When the last ice age ended around 11,600 years ago, sea levels rose by approximately 120 meters. That is nearly 400 feet. Coastlines that had been habitable for thousands of years were inundated, drowned beneath hundreds of feet of ocean. And where do civilizations build? On coasts, near rivers, in fertile lowlands, exactly the places that would have been submerged when the ice sheets melted. If an advanced civilization existed during the Ice Age, when sea levels were 120 meters lower than today, their cities would now lie beneath the ocean. Their ports, their trade routes, their agricultural centers, all underwater. We have barely begun to explore the continental shelves, the shallow underwater plateaus that were once dry land. But what we have found is tantalizing. Underwater structures off the coast of Japan near Yonaguni that appear to be carved from bedrock. Massive step pyramids and platforms that some geologists argue are too regular, too geometric to be natural formations. Underwater ruins off the coast of India near the Gulf of Kambat, dated through carbon testing to 9,500 years old. Submerged structures in the Mediterranean, off the coast of Cuba, near the Bahamas. Each discovery is controversial. Each is disputed by mainstream archaeology. But the pattern persists. Underwater stone structures in multiple locations around the world, dating to the end of the last ice age. What if these are not anomalies? What if they are exactly what they appear to be? The remnants of coastal civilizations that existed before the flood, before the sea levels rose, before the world we know came into being. The Younger Dryas period, from approximately 12,900 to 11,700 years ago, was a time of catastrophic climate change. After thousands of years of gradual warming as the Ice Age ended, the climate suddenly reversed. Temperatures plunged, glaciers advanced. Then, just as suddenly, the cold period ended and rapid warming resumed. The ice sheets collapsed. Meltwater poured into the oceans. Sea levels rose at rates that would have been catastrophic for any coastal populations. Some researchers, like Graham Hancock, have argued that this period also saw impact events. Fragments of a comet or asteroid striking the Earth, causing massive fires, triggering the climate instability and accelerating the ice melt. The evidence includes impact markers in the geological record. Nanodiamonds, microspherules, and platinum anomalies found in sediment layers dated to the beginning of the Younger Dryas. A global layer of carbon suggesting widespread fires, extinction of megafauna across North America and Europe. If an advanced civilization existed at that time, such an event would have been apocalyptic. Imagine a world-spanning culture built along the coasts, dependent on maritime trade, thriving during the stable climate of the late Ice Age. Then, in a matter of days or weeks, impact events, massive tsunamis, climate collapse, and over the following centuries, the slow, relentless rise of the seas, swallowing cities, erasing coastlines, forcing survivors to flee inland to higher ground, to places like the Nile Valley. What would survive such a catastrophe? Not libraries, not records written on organic materials that decay, not cities built at sea level, but stone monuments, structures built on high plateaus, knowledge encoded in forms that could outlast the deluge. Mathematics, astronomy, geometry. The survivors would carry what they could, fragments of the old knowledge, seeds of the old sciences, and they would try to rebuild. But they would be few in number, scattered across the world, cut off from each other. The global civilization would be gone. What remained would be isolated pockets of refugees, struggling to preserve what they remembered. This is the world the ancient myths describe, the flood stories that appear in cultures across the globe, the Sumerian epic of Gilgamesh, the biblical story of Noah, the Hindu tale of Manu, the Greek legend of Deucalion, the Aztec myth of the Five Sons. Over 200 distinct flood narratives from cultures around the world describe a time when the waters rose and the old world was destroyed. We have dismissed these as myths, but what if they are memories? What if the Great Pyramid was built by the survivors, not as a tomb but as an ark, not an ark that floated but an ark of knowledge, a structure designed to preserve the understanding of a dying civilization, the mathematics encoded in its dimensions, the astronomy encoded in its alignments, the physics encoded in its acoustics, all of it waiting for a future generation to rediscover and decode. This would explain so much. Why the pyramid appears fully formed with no experimental predecessors. Why its precision exceeds what the Egyptians could replicate in later pyramids. Why it encodes knowledge of the Earth's dimensions that would not be officially rediscovered until the age of satellites. Why it points to stars as they appeared in 10,500 BC, not 2,500 BC. Why it shows erosion from rainfall that ended before Egypt's dynastic period. Why it is anonymous, carrying no clear inscription of its builders. Because it was not built by one civilization. It was built by one, claimed by another, and inherited by a third. The original builders, the civilization of the first time, constructed the core in the age before the flood. The pre-dynastic Egyptians found it, cleared it, and revered it. The dynastic Egyptians, starting with Khufu, appropriated it and added their own layers, and we, the modern world, stand before it now, trying to piece together a history that spans 12,000 years or more. But if this is true, if the Great Pyramid is a monument from before the flood, then it is not unique. There should be others, other structures built to the same purpose, other arcs of knowledge scattered across the world. And when we look, we find them. We find Göbekli Tepe in Turkey, built at the same time the Orion correlation suggests for the Giza layout. We find the Sphinx, with its water erosion dating to the same era. We find Tiahuanaco in Bolivia, with its precisely cut andesite blocks and astronomical alignments. We find Nan Madol in Micronesia, a megalithic city built on artificial islands. Its construction date unknown, but its basalt columns weighing up to 50 tons, transported and placed with unknown methods. We find the stone spheres of Costa Rica, perfectly round granite balls weighing up to 15 tons, scattered across the jungle with no known purpose. We find Puma Punku in Bolivia with its H-blocks cut so precisely that they interlock like Lego pieces, their surfaces flat to within fractions of a millimeter. Everywhere we look, if we are willing to look, we find evidence of advanced stoneworking, astronomical knowledge, and mathematical precision in structures that predate the accepted timeline of civilization. The pattern is global, the precision is consistent, the knowledge is profound, and the conventional explanation that primitive people with primitive tools somehow achieved all of this through trial and error becomes less convincing with each new discovery. So, we return to Giza, to the Great Pyramid, the largest, most precise, most studied ancient structure on Earth, and we ask again, what if it was built long before the Egyptians, not as a tomb, but as a marker, a monument to a lost age, a time capsule containing not artifacts, but information, a three-dimensional equation encoding the knowledge of a civilization that knew it was about to end. They could not save themselves. The comet had struck. The climate was collapsing, the seas were rising, but they could save their knowledge. They could build something that would outlast the catastrophe, something future generations would find and wonder at, something that would make those future people ask questions, seek answers, rediscover the old sciences. And perhaps, when the cycle came around again, when the next cataclysm threatened, be better prepared. This is speculation, yes. But it is speculation built on evidence. The water erosion is real, the carbon dates are real, the astronomical alignments are real, the mathematical encoding is real, the precision is real, the absence of evidence for conventional construction is real. What is speculative is the framework we use to interpret these facts. And the framework offered by mainstream archaeology, that Bronze Age Egyptians built it in 20 years with copper tools, requires us to ignore too much evidence, to dismiss too many anomalies, to accept too many impossibilities. The alternative framework, that the pyramid predates Egypt and represents a lost chapter of human history, requires us to accept only one impossibility: that civilizations rise and fall across spans of time deeper than we have acknowledged, that we are not the first to achieve advanced knowledge, that history is cyclical, not linear, and that amnesia is not just personal but collective, civilizational, spanning millennia. Which is more impossible, that people with copper chisels carved granite with precision matching modern machining, that they transported 80-ton blocks 800 kilometers and lifted them 150 meters into the air, that they encoded mathematical constants they supposedly did not know, that they aligned their tomb to stars they could not see and a precession they had not discovered, or that an earlier civilization, now lost to time and flood, achieved technological sophistication we are only now rediscovering. The evidence, when examined without preconception, points to the latter, but accepting that evidence requires humility. It requires admitting that we do not have all the answers, that our timeline might be wrong, that our understanding of human history might be incomplete, that there might be chapters we have not read because we refuse to believe they exist. The Great Pyramid challenges our assumptions. It stands as a monument to the limits of our knowledge. Every measurement we take reveals new mysteries. Every technology we apply uncovers new questions. The muon scans show hidden chambers we cannot access. The seismic surveys reveal tunnels we cannot explore. The acoustic tests demonstrate resonance we cannot explain. The mathematical analysis encodes relationships we barely understand. We have studied this structure for thousands of years, and we are no closer to understanding its true purpose than the ancient Greeks who wondered at it, or the medieval Arabs who explored it, or the Victorian archaeologists who blasted into it. Each generation thinks it has solved the mystery. Each generation is proven wrong by the next. Perhaps the mystery is the point. Perhaps the pyramid was designed not to give answers but to provoke questions, to make us think, to make us search, to make us realize that we do not know everything, that there is always more to discover. In the end, the Great Pyramid is a mirror. It reflects back whatever we bring to it. If we come with certainty, it shows us the limits of that certainty. If we come with questions, it gives us more questions. If we come with humility, it reveals glimpses of how much we have forgotten. And if we come with open minds, willing to follow the evidence wherever it leads, it offers us the possibility of a different history. A deeper history, a history that acknowledges human civilization as older, more cyclical, more fragile, and more remarkable than we ever imagined. The stones of Giza have stood for thousands of years. They will stand for thousands more, long after our current civilization has risen higher or fallen away. The Great Pyramid will remain, silent, precise, eternal, waiting for the next generation to stand before it and ask the ancient question, who built this? And in asking that question, to discover something not just about the past, but about themselves, about what humans are capable of achieving and what we are capable of losing. As the stars wheel overhead, the same stars that shone when the pyramid was new, whether that was 4,500 years ago or 12,000, Orion rises in the east. The 3 stars of his belt align just for a moment with the 3 pyramids below. The geometry holds, the alignment persists. The message, whatever it is, continues to transmit across time, and we, standing in the 21st century with all our technology and knowledge, are finally beginning to receive it. What if the Great Pyramid was built long before the Egyptians? What if the greatest monument ever constructed was not a tomb but a warning, a promise, a reminder carved in 6 million tons of stone that civilizations rise and fall, that knowledge can be lost and found again, that the story of humanity is longer and stranger than we dare to believe? What if the ancients were not primitive but different, their science expressed in stone and star rather than circuit and screen? What if we are not the pinnacle of human achievement, but simply the latest chapter in a story that began long before us and will continue long after we are gone? What if everything we know is wrong? These are the questions the Great Pyramid asks, and the only honest answer is this: we do not know, but we are still searching, still measuring, still wondering. And perhaps that is exactly what the builders intended. For the pyramid to stand as an eternal question mark, a stone enigma at the edge of the desert, challenging each generation to look deeper, think harder, and remember that the past may be far more mysterious and magnificent than we ever imagined. The wind picks up across the Giza plateau, sand swirls around the base of the Great Pyramid, the guards lock the gates, the lights dim, and in the darkness the monument returns to what it has always been, not Egyptian, not human, but something that transcends both, a structure that belongs to time itself, built by whoever had the knowledge, preserved by whoever had the will, and inherited by all of us, the ones who came after, the ones who must decide what to do with this impossible gift from an impossible past. The Great Pyramid stands, the questions remain, and the search for answers continues, as it has for thousands of years, as it will for thousands more. Because some mysteries are not meant to be solved. They are meant to be lived with, wrestled with, wondered at. And the Great Pyramid, whatever its origin, whatever its purpose, has given humanity one of its greatest gifts, the gift of mystery itself, the reminder that we do not know everything, that there is always more to discover, that the universe is stranger than we suppose, and that sometimes the most profound truths are hidden in plain sight, waiting in massive stone monuments for someone to finally see them.